Now we'll try the h3 example. Let's go ahead and edit that. So here we are in h3. It is performing, again, a matrix vector multiplication, storing the results into an array that's allocated within the function. And then down here we see that it's just simply performing that and then displaying the values. Now there is one significant difference between h2 and h3, and that is this does not free the vector. Will that cause a problem? Let's find out. If I go ahead and compile it and run it, I get the results as specified by the lab instructions. So no, that free doesn't actually cause a problem. The lack of a free does not actually cause a problem. And this is generally true. It can lead to memory leaks if you repeatedly allocate but not free. So let's try that. Let's go ahead and add our loop code in here. So we'll create our loop variable for I is equal to 0, I is less than 5, I plus plus. And terminate my loop, write it, make it, and run it. And as we can see here, it just simply outputs the same thing over and over again. So no problem here, right? Not necessarily. One of the things it does suggest is if we come in here to edit, and we actually do 2 matrix multiplies. So I'm going to actually create those 2 pointer variables, and then I'm going to store 1 matrix multiply in 1 pointer and the other one in the other pointer, and then show the vectors. There's y1 and y2. Still inside the loop. Let's go ahead and write this. Make it. And run it. Now we get very, very odd results. You'll notice that y1 is becoming corrupted partway through. So we get 6 good values, but then we get 2 invalid values, and then we get 2 more values that look correct. But y2 is completely correct. The problem that we're seeing here, if we go back to the source code, is that this call to matrix times vector is allocating 1 array, and this one's allocating a second array. But the second array that's being allocated is actually modifying the array that came first. And why is that? Well, let's take a look up here. Here's our matrix times vector function. And if we take a look, here's our allocate. Now we are allocating n, and n is defined up here as 10. This allocates 10 bytes, not 10 integers. And so when we come through here and we assign values to y, which is assigning integers, which are usually 4 bytes apiece, we're actually going easily over the end of this array. This array is being allocated 10 bytes, but we need 40 for this to work properly. If we want to fix this problem, what we need to do is insert a multiplication of n to the size of integer. Size of int returns a 4. N being 10, this gives us the 40 bytes that we need for this code to be successful. And if we go ahead and run this, h3, run it. We should get all the correct values we need.